Thank you, Carlo. Am I audible to everyone? And I'm assuming that's so. So, welcome everyone to this NSO in Docker session. And I want to start by thanking everyone for spending their time. And we truly appreciate your time. And we will make sure that we provide some important learnings on this great topic of NSO in Docker. So, to begin with, our agenda looks like this. It's divided into three parts. We will be focusing the first part on the what and the whys. It's very important to know that what is NSO in Docker about and why do we use NSO in Docker. After we complete the what and the whys, we are going to be going down the house. It's very important that we give you the ability to learn the steps of deploying NSO image and running the NSO image as a container within your own laptop or within your own systems. But keep in mind that NSO in Docker is not supported by TAC as of today. So please use NSO in Docker primarily in your development and test use cases. So that is something that we want to make sure that we highlight. NSO in Docker is very flexible, and we are sure that you're going to love what you see and what you see the demo in this particular presentation. So without further ado, let's start with some of the basics of virtualization, because the underlying technology today that we are using in both VMs and in containers are the virtualization aspect of it. We started using virtual machines, and I am pretty sure that virtual machines form 80% of the data center stack quite a few years ago. However, virtual machines are considered now as bottom heavy. What do I mean by bottom heavy? When we say bottom heavy, each virtual machine has to operate within the context of its own OS. So that makes it bottom heavy. As you can see in this slide, that there are three virtual machines in a single host platform. When we refer the host platform, we are talking about the hardware platform itself. So if I take an example of VMware, ESXi is considered the hypervisor that communicates to each virtual machine and provides the guest OS access to the underlying CPU, memory, and storage. So virtual machines are still used in the data centers and to a certain extent in the cloud itself, but they were primarily the first step in virtualization. And we have successfully deployed virtual machines for many, many applications. From virtual machines, we take a right turn primarily to reduce that uh, bottom heavy part of it. Like we have seen that each virtual machine has got its own operating system. In the context of virtual containers, that OS, individual OS operating system within VM is completely taken off, and our focus is on the applications. And we are providing the applications with binaries and libraries that provide them access to the underlying operating system through the Docker engine. Now, the Docker engine acts similar to the hypervisor in the context of virtual machines, but the Docker engine communicates with the Linux kernel using C groups and namespaces. So that is the main difference between a virtual machine and the containerization based on the Docker engine. We have other open source containerization technologies, but in the context of this particular presentation, we will be referencing to Docker. Now, this slide primarily, kind of repeats what I have mentioned in the first slide, but we are trying to compare the two side by side. And what I want you all to take uh, away from this particular information is that in the context of containers, there is less code and it's easy to transfer, migrate workloads. However, in the context of security, VMs are still the main approach of using virtualization in order to reduce the footprint from a host infrastructure perspective. So two takeaways from this slide. For security controls, VM is still running, and we have NSO, which is the Network Services Orchestrator, the main key component, main key product or solution that we have within our orchestration portfolio that Cisco provides. So, two takeaways: security, refer to virtualization through VMs. If you have a lightweight, quick, quick win approach, use containers, and that's where the why comes. Why do we use NSO, and why are we recommending NSO in a Docker container environment per se? Now, within Docker, right, not going through the details because Docker is a subject matter itself. What we would like to explain quickly that within a Docker perspective, we focus on four important aspects of it. A is the image. When we download the image, it's just an image, it's not a container. A running image is what considered as a container. So that is one clear differentiation that I want to make, that if you download an image, Docker image from the Docker Hub or within the context of NSO installed images, you are just downloading the Docker image, but once that image runs or you are executing the Docker command line Docker run, you are actually running the container. Along with the container, we want to make sure that we map a volume to the running container. So volume is also an important option when you make a Docker image to run as a container within your environment itself. Networking, the Docker containers talk to each other within the single host itself. But if you are trying to connect Dockers across multiple hosts, then you will have to use another orchestration, which is not in scope of this presentation, but primarily you will be talking about Kubernetes. So within the Docker containers basics itself, the main important points are the Docker image, the Docker container, the volume, and the network. Now, we use Docker images in the context of a client and a Docker host. But in most cases, our laptop, which is a quick and easy platform that we use for testing a particular application or testing a Docker container. So in this case, what we'll be using is a Docker client and a Docker host within the single laptop or an infrastructure or the physical device itself. However, Docker also leverages the Docker Hub website. Say, if you want to download an image or you want to run an image, Docker first checks if that image is locally available. And if it's not locally available in the Docker image part, it will go to the Docker website and download that image. So that's how the Docker images are downloaded in real time. If you are downloading a NGINX image, and if you have not loaded the NGINX image within your platform itself, the Docker pull will look at the local cache, and if it doesn't find it, it will go and download it from the registry itself. Now, the important part is that in the Docker build, Docker pull, and Docker run, you can clearly see that each of these lines are differentiated with multiple different dashes because they communicate with the containers and the uh, image subsystem itself. And if it doesn't find it, it will talk to the Docker daemon, which will then again go to the Docker registry and download that particular image file. So these are the basics of Docker. As I said, our approach is to spend time in explaining NSO in Docker, the focus being the network services orchestrator. Now, quickly giving the benefits of Docker containers: speed is number one because it's lightweight. When you are lightweight and you are bottom light, you are obviously going to boot up fast. The second part is portability. There are less dependencies between the process layers and between the infrastructure. Like, as I said, the Docker engine talks to the Linux kernel through control groups and namespaces. And finally, if you add speed and portability, you will lead to efficiencies. The less efficiency, The important part is that you don't have to maintain and patch an individual OS that is available within the virtual machine itself. So these are the important pointers that we would like to set as a primer to our next step, which is the NSO in Docker. That's the key subject of this particular webinar. Now, the important part of why NSO in Docker, right? So testing is an important part of every production environment. Like, we would like to measure it twice before we deliver it once, right? So in that context, a lot of engineering teams and folks want to have a reliable system where they can see what is deployed in production, but use a subset of the production in their development and stage areas. And that's where the answer for why NSO in Docker comes to. So we have provided you, or we have provided you the Docker images within the NSO installer file itself. Now, that is a very key important point, that you do not have to build your own Docker images using complex Docker compose files. If you do want to customize this, we do give you the ability, but we are confident that the images that we provide you within the NSO installer file itself are good starting points in order for you to test the NSO release version, or a particular package that you have deployed it in production. So that underlines the why part of it, like testing the combination of NSO 5.7 with 5.8 or with 5.9, because we do know that when you go from one release to the other, there are times where you have to redeploy NED in order to make sure that it is backward compatible. So this gives a huge benefit of testing the environments in a lighter context, not using heavy resources like what you call uh, infrastructure that comes at a very expensive proposition. Having NSO in a container makes it very easy to start, like I've explained before. And the benefits of NSO in a Docker system, that you can combine the two packages or the two images that we provide you, and you will see that later in our presentation, as well as in the demo, where you can utilize your packages or a combination of packages within the NSO base image or the NSO dev image, and then make it as a runtime container so that you can run particular tests against those containers that you have specifically built in order to test your use cases. So it is a very efficient development type that you can deploy quickly, and you can test your use cases and document your results as well. Now, how do we go about in deploying NSO in Docker? So from a prerequisite perspective, as you can see, it's simple. We support NSO in Docker in Linux, which is obvious. We do support it in Mac OS as well as in Windows. Now, in order to make it much easier and much simpler, we have a GitHub repository, which is the foundational layer for you to download the NSO Docker images, and then take it from the NSO Docker images, do your computations, and then spin up the container itself. So this website, please, the one thing that I want you to take away is this URL. Now, this URL will also provide you with very good README files that are very easy to understand and execute based on the instructions. And major part of this presentation is derived from the instruction, because we want to make sure that what's out in the public domain, we align this presentation with the information in the public domain, so that when you execute this Docker image as a container, you have all the steps required. Like, as I said, our goal is to empower you as a user, as a test engineer, as an architect, to leverage NSO in your dev test environment and then bring it into production. to build the images, like apart from the Docker image that we provide you through the installer bin signed bin file, we also want to make sure that you download from your package system. Say you use the Ubuntu version of Linux or the Red Hat version of Linux, you have to download through that package manager like apt-get. Make sure you download two important packages. One is the core utils and the other is the make. So remember this, the second bullet point, that you need to download make in order to um, process the signed install NSO installer signed bin file and make it into a container. Um, all of the current Linux distribution systems come with Python 3, but we just want to make sure that you are aware that Python 3 is a requirement in platforms other than Linux. We know that Linux comes with Python 3, Mac OS comes with Python 3, but in Windows, if you're running Windows and within Windows you have a dependency for Python 3, make sure that you install Python 3 within that within the requirements for Windows 10 per se. So like as I said, core utils and make are the two packages that you would want to install in your Linux system. And if you're using the Mac OS, most of us install Homebrew. And after you install Homebrew, leverage Brew to install core utils and make. And these steps, as you will see, that we have um, taken the steps and we have aligned our demo. So when you are finished with this webinar, it will be much easier for you to align the presentation as you see the demo, and then we expect that you will be very confident in to download this image and do the step-by-step installation of NSO in Docker. Now, from an overview of containerization with Docker, how do we get the Docker software? Now, as I said, normally, if you want to get a public image from Docker, you go to the Docker website, which automatically happens if you do not have that image in your local cache. And in some of the cases, you create your own image using the Docker compose file steps. In our case, we have the two Docker images within the NSO installer itself. So the second point that I want you to take away, the first point being the URL, which is the key important steps or document that you would need to deploy the NSO image in runtime. The second important point is that we have provided you the NSO image, and we will show that to you in our demo as well. Now, this is more of helping you all align the steps with what you will see in a few minutes about how do we get about in terms of deploying NSO container in our dev test environment. The first step, as I said, you'll have to do a git clone with the repository URL that we have provided with you. The next step is you would have to go to the CCO site, and if you are a partner, you would have access to CCO. If you are not a partner, you can also obviously go to the developer.cisco, which is our DevNet website, and you can download the free version of 6.x. It's in order to experiment or in order to try the steps that we have mentioned. Like once you go to the website to the software download section, you would see the different versions of NSO. And the important thing is that you have to download the signed, depending on the platform that you use. I'm assuming that you would start with Linux. If you are going with Linux, be careful. You have to look at the signed d.bin file. It is a self-archive, self-extracting archive that verifies the signature. And once you have downloaded the installer file, like you can see that once you run a bash or a shell against the signed build, it will automatically produce a number of files. Out of those files, the NSO installer.bin is an important file. Now, another key point that I would like to mention, that when you are cloning the GitLab repository, it will create two directories for you. One would be the NSO-Docker, and the other will be the NSO install files. Now, after you have decompressed or unarchived the signed bin file, you would have to move the installer file. Now, this is another important step, and you will see that in the demo itself, that you will have to move that file into the NSO install file in order for you to go to the next step. Now, there are times where you would like to leverage your same system or a same platform to run multiple instances or multiple containers of NSO with different releases. And if you are doing that, you have to make sure that you specify the NSO version when you are running the make build command. So that is another key point that I want you to take away from this presentation. And you will see this in the demo itself. And once you get the recording, you can run it a few times, and I'm sure that in one or two times you will able to execute this very successfully. Now, as I mentioned, the Docker image files are being delivered to you, and this is a huge advantage. We are trying to save your time on focusing on the service creation aspect or the orchestration capabilities and features of NSO. So as a result, we provide you with two images. The first image is the NSO base image, and the second image is the NSO dev image. We recommend that you start with the NSO base image and then add the subsequent packages to this image once it's running in a container runtime format. And this will help you understand the how the steps from image to container works, and how you can step by step or incrementally add packages to your NSO base image. Now, once you get confident with building from the base image within your dev test environment, we would like you to pivot into the next image once you are fully confident and you are able to execute it with less time. We would want you to look at the NSO dev image, and this image has got the Java libraries and a lot more packages that you can select within that packages and then compile in order to create a custom NSO container that has the specific packages that you have selected in the context of the NSO dev image itself. So that is a key point. But we recommend that after this webinar, you start with the NSO base image, and we will do that demonstration as well, where we will leverage the NSO base image itself. Now, as I said, verification is a key important step. Once you have run the make file, you would go into the Docker command line and run Docker images, and you will see these two images. Like I mentioned, they are a part of the NSO installer bin file itself. And these are some of the steps that you will have to take. One is mapping of the volume for your NSO container to read write data once it's in runtime. So you will have to build a directory, very simple, do a make dir NSO data. And once that directory is created, when you are running the container or running the Docker run command in order to convert the image into the Docker container, leverage these options, right? Interactive terminal detached, make sure that you have HTTP enable, which is an environment variable. In order, if you are more inclined towards leveraging the GUI NSO features or capabilities, make sure that you do HTTP enable equals to true. The admin username is primarily for you to log in as an admin with the password, and the -v is the volume. Like as I said before, we have to map a local directory to the NSO container so that it can store and read and write files from this particular volume. So these are the steps that you will see in the demo. We want to give more time to the demo itself. So I've kind of gone to some steps pointing the key data points because I want to make sure that you relate to what you have heard so far and ask question to our panelists. We have a good panelist that have got excellent knowledge with NSO and will answer all your questions related to NSO and Docker. So I strongly recommend that while you have seen this presentation and while the demo is going on, please ask questions to get clarifications. Now, I want to quickly summarize what we have learned so far, or what we have understood so far, is that the containers allow you to separate your applications. This is primarily the 101 of containers from your infrastructure. NSO is no different than what the benefits of containers allow. So that's why we want to make sure that NSO and Docker is leveraged in your dev test environment. Um, the quickness, or you can rapidly deploy NSO Docker images. I've explained to you how that can be achieved. Docker is lightweight, it's not bottom heavy unlike VM, and you can combine your package with the base image to create a custom Docker container. Now, one of the most important use cases you will see in the future or even now is how NSO Docker can be used in a test dev environment in a context of an automated CI/CD pipeline. We call it as the test automation framework, and you will get more details on it on our website as well. That how do we leverage NSO in Docker within the context of a test automation framework. So, folks, I would like to provide you with some more details on if you want to further continue, and depending on where you are in the NSO knowledge space, leverage these links. These links provide you with hands-on sandbox activities as well as curated teaching from the basic to intermediate to expert. And also, if you want to have ATX sessions, ask the expert sessions, or leverage some deep dive NSO sessions provided by Cisco customer experience, then talk to your account manager and system engineers. And we have a lot more content on NSO delivered via Ask the Experts and the Cisco Accelerator. So these are the two links that please refer to in order for you to continuing learning to become the NSO expert. And finally, I would want to kind of hand it over to Miguel, um, where we will show you exactly what we have presented and how we can take the NSO image from scratch and then make it as an NSO container. So Miguel, handing it over to you.
Thank you, Aswan. Let me share my screen. Okay, can you see my screen?
Yes.
Okay, great. Hello, my name is Miguel Valdivia. I'm a customer success specialist for service provider. During this demo, I'm going to demonstrate how to create an NSO in Docker image and how to run a container. Okay, in this demo, I'm going to use a Linux machine. In this case, I'm using a Ubuntu. You have some prerequisites that you need in your system. In this case, you need Docker. Just 1 second. So be sure that you have Docker installed in your system and these utilities that will be core utils and make. Okay, so once you have this installed in your system, now you need to understand that running NSO in Docker is not as simple as go directly to Docker Hub and look for NSO image. So basically you need to create the image. In this case, Cisco has created a repository that is public available. So the only thing that you need to do is to clone that repository, and in that repository, you will find all the instructions that you need to produce a Docker image. The only thing that you need to provide is the binaries, the installer binaries. So this is the repository. Here you have some files, some directories. You have, this is a very good for CI/CD pipeline, but today we are going to focus only on how to create the image and how that it works, okay? The first thing is that almost all the interaction in this, almost all the interaction in this repository is done by make utility. Basically, make utility is going to call make file, and in the make file is going to be defined the tasks that are going to be executed. This is going to be in background. The idea here is that you don't have to face these complexities of creating this image. Okay. So the other thing that I want to show you is inside of the Docker image is where everything is going to, is where the NSO in Docker is going to be created. So here you have another make file. If we look inside of this make file, you will find that we have Docker build, and we have this Docker build 2 times, okay? And why we have 2 times? Because when we create a NSO in Docker image, you are going to have 2 different images. The first one, the Cisco NSO dev, and the other one, the Cisco NSO base. The dev will be a very good image for development because you have Java compilers, you have useful tools for development, and the base will be good for production environment because it's going to be smaller. So you're not going to have too much documentation. You're just going to run the necessary, you're going to have the necessary compilers that, to run NSO, okay? And since you're running Docker build, that means that you are going to call a Docker file to build the image, okay? So in this Docker file, you will find all the instructions to build a Docker image, okay? You can go through these files, but it works pretty well. So if you want to modify something, you can do it, but it's going to work pretty well. You're going to see that. But the only thing that I want to show you here is that inside of that NSO in Docker, you're going to have a system install, okay? And if you're familiar with NSO, usually by default, the running directory you will find in /var, /opt, /ncs. In this case, we are going to have the running directory in NSO/run, and the logs directory will be here. So this is important for when we are going to create the volumes. Of course, you can find this in the documentation, but I want you to show you where you can find the details how these images are built. Okay. The next thing that you need to know about this repository is that you need to put the installer binaries inside of this directory, NSO install files. Okay. So what you need to do right now is what you will need to do in this case is to go to Cisco downloads or NSO downloads Cisco. Here you go to software download. And you will need to choose the image that you want to have the NSO image. In this case, I'm going to use the release 6. You will need to download this specific Linux installer, NSO 6.0 Linux signed beam. I'm going to download another one that will be the release 5. I'm going to download this one, 5.8.4, the same orchestration Linux installer. And finally, to do some tests, you will find here some nets in Network Service Orchestration free trial. So if you log in here, you will find some nets that are available for free trial. I'm going to use the IOX XR net, okay? I already have these files right here in downloads. So I have the NSO signed beam, NSO 5.84 signed beam, and I have the net. So the next thing that you need to do here is to unpack these files. So you just need to do sh It's going to verify some security, verify the signature, and that's it. So you will get different files, but what you need to put inside of the repository files is this installer bin, okay? So let's do it right now. Just 1 second. And I'm going to unpack the other release as well. And again, I'm going to put this file inside of the NSO install files. Okay, that's it. So let me show you this. Okay, so inside of NSO Docker, that is the repository that you download from internet or from GitHub. Inside of NSO install files, you will have these installer binaries. Okay, so the next thing is that you need to be inside of the repository, and then you need to create the image. Okay, let me show you that I don't have any image right now in Docker. I don't have nothing here. Yes, I don't have any container. I don't have any image. Okay. So here you have two options. You can do make all. With make all, you are going to have you are going to build the NSO in Docker for both versions, for the version 5.8.4 and for the version 6.0. Or you can choose the version that you want to build with this command. NSO version 6.0 make build, and you're going to build only this specific release. Okay, so right now it's building, is getting some information, and it's building the image. I already have some information in the cache. For that reason, it was very fast. Usually, it will take 2 minutes, 1 minute to create the image. Okay. So let me show you here that we already have two images, okay? We have the NSO base and we have the NSO dev. And you can see that the dev is heavier than base because, again, dev is for development. So you have compilers, you have utilities for development. And in the case of base, what we want to have is a very small image just with that necessary information to run NSO. Okay, for that reason, it's very small. Okay, so the next thing that I want to show you here is that you have the release with a suffix. This suffix is going to be the user of your system where you are creating the image. Okay, that is good because in the case that you already have this image in your Docker images, and you want to build a new image, it will be overridden if we only have this version. So for that reason, we are adding this suffix to avoid that condition. Okay, of course you can retag the image. I'm going to just put NSO 6.0. So right now we have these two images pointing to the same image ID. Okay, so we are going to get rid of the 6.0 with the suffix. Okay, so Docker. So right now you only have this one. You can do the same with dev, but today we are going to work only with base. Okay. Now, the next step will be to create a container. Okay, and to create a container, you have different options. But the first thing that I want to explain to you is that containers by nature are ephemeral. So you might expect that in some point in the time, the container is going to stop, is going to be reboot, or is going to or maybe it's going to be deleted, okay? And you are going to build a new image, and you don't want to lose information. So because NSO, the state data, the running information is very important, okay? So for that reason, we are going to create volumes, okay? So the idea of the volume is to save that information even if the container stop or is removed, okay? So let's create our first container. So the first thing that you need to do is create a directory where you want to save the information of the NSO. So I'm going to create this directory. So inside of this directory, I'm going to save all the information that we are going to create, that we are going to run, all the packages that we are going to run, the logs as well that we have inside of the NSO Docker, okay? NSO in Docker. The next thing will be to run the container. For running the container, you have different options. You can go to the documentation and you will find that you can set different variables, environmental variables. So in this case, I'm going to use this command, docker run it. These are some flags. So this is interactive, TTY, and detach. Then the name that I want to call this running container. Then the environmental variables, I'm going to enable HTTP. Here, the admin user, I'm going to put Cisco. If you don't set this environmental variable, by default, it's going to be admin. You need to set the password for the admin user. I'm going to put admin. And here, I'm going to start mapping the port of the Linux machine, because remember that this is running inside of a container. So you have the Linux machine, the IP address of your Linux machine. So when a request arrives to the Linux machine to the port 80, it's going to be translated inside of the Docker container to the port 80. And by default, the NSO in Docker use the port 22 for CLI. So since I'm using the port 22 to connect to the Linux machine, I'm going to use the port 2024. So if a request arrives to the port 2024, it's going to be translated to the port 22 inside of the Docker container. Okay? Then I specify the volume. This is what is going to help to keep the running information always alive, even if the Docker container is stopped. Okay, so we are going to copy the /NSO. And if you remember, when we create the image and we did the system installation in the image, we are saving the running information in /NSO. So basically, I'm copying that information in this directory. And as well for the log information, because keeping the logs is important as well in NSO, I'm going to copy the log information that inside of the container is in /log. I'm going to copy that right here. Okay, and here you specify the image. That's it. It's creating the container. So it's starting the container right now. It's up. So in 9 seconds, you have a NSO running right now inside of your container. So that is very fast, okay? So let me show you how to connect inside of the container. So I'm going to use Docker sec it. Here you put the container ID #L. So here you're inside of the NSO in Docker, and this is like any other NSO in system install. So here you have the NSO directory. In NSO directory, you have the run, and here you have packages where you are going to put the next, the package that you want to deploy. You have here the CDB, the backups, rollbacks, everything is here in the running directory. And in log, you will find all the normal logs that you will find in an NSO. Okay, The other thing is in etc NCS. Here you have this NCS conf, and here are some the information, the configuration, the basic configuration of the NSO. So for example, here you have the CLI is using the port 22. Okay, so if I want to connect directly to the port 22, this is the IP address of my Linux. This is the IP address of my Linux. I'm going to use the port 2024. So I'm going to connect here. This is the user that I defined in the variables, and I'm inside of the NSO. By default, it's going to use a Juniper style, but you can change that as well in the environmental variables to Cisco style. And the other thing is you can connect using web as well, because I enable the port 80. So here you are in the web UI. Okay. Okay, so let's do something else. You admin, sorry, Cisco. Okay, so I'm inside of the CLI. I'm going to show you the configuration. So running, okay, this is the default configuration. So what we are going to do right now is to install a package. We don't have any package right now. So we are going to install the net, okay? So I already downloaded the net. This is the free trial that I mentioned to you. So again, you need to unpack this file. And you need to put this file inside of the running directory, okay? So let me do it right now. Here. So what I'm doing is copying this file inside of NSO data. That is the directory that I map inside of the NSO container, NSO run and package. So I'm going to copy there. Sorry, sudo. It's done. Okay, I'm going to connect again to the container. NSO run package. You have this net. So I'm going to connect to the CLI. So basically what I'm doing right now is to install this net in the Docker that is in the container. It's going to take just a few seconds. Okay, it's done. Okay, show package operator status. Okay, so you have the net installed in your system right now. What else? You can create a configuration inside of the NSO as a normal NSO group. Let me create this one, lab one, then default map. Cisco and default map and remote password Cisco 123. Okay, let me commit this. So here you can find the configuration. Okay, the other thing that you can do here is in package, you can develop your own package here as well. So this is the normal way that you can use to develop a new package. Okay. So now let me show you a different approach to create a container. So Docker PS, I'm going to stop this container. Stop. Okay. So I don't have any image right now. So what is the problem with this command? It's not a problem. It depends on the way that you want to do it. So basically, you need to define port by port here. You need to map that in the container. Okay, so for example, if you are going to connect with an external controller and you want netconf, you need to enable here as well. You need to map that port with netconf. Another way to do it, to do the same, is with this command. Uh, all the variables, everything is the same, but I'm changing the SSH port to the port 2024. And basically, I'm mapping with this command the IP address of the Linux server to the Docker container. So that is part of the network space. Okay, the port 22 is going to keep the Linux machine, so I can connect to the Linux machine. But now to connect to the CLI port, I'm going to use the port 2024. So I'm going to create this container. So it's starting. It takes a little longer because this mapping takes more time. Okay. Okay. So now it's up and running. Let me show you here. Docker PS exec IT. I'm going to copy this. -L. And here, I want to show you what was the change. It is NCS, more NCS conf. So when I change that variable, you're going to see here in CLI that will be here that right now is not the port 22 anymore, it's the port 2024. So I can connect again from here. Okay, so I'm connected there. And the other thing is that you have everything, right? For status, you still have the net, and you still have the configuration that you did because all that information was saved in that external volume. So when I stop the container, when I delete that container, all that information keep safe in the Linux machine. So for that reason, when I map again the same to the same volume, all that information was copied inside of this NSO and you keep that information. Okay, so that is what I want to show you in this demo. I hope that you enjoyed. Thank you very much, and back to you, Carlo.
Awesome. Thank you very much, Miguel. All right. So at this time, we'll go ahead and take some questions from the audience members. Uh, Again, if you have a question for our presenters, um, our panelists are ready to respond. Please use the Q&A window as opposed to the chat. That way we can get those answered accordingly. All right. Let's see here. First question I have, and any other panelists can unmute their microphone as well and talk about it. But here it is NSO in a Docker environment recommended for smaller production environments?
Um, I'll answer that question. This is Oswald. So, as much as it looks exciting and you can have a lot more, you can do a lot more for NSO in Docker, we do not recommend NSO in Docker to run even in small production systems. That being because it's not supported by TAC, and the second being is that your small business has got could have multi-vendor devices. For that, you would have to get licenses that have to be installed within the context of your NSO and Docker. And more or less, Docker CDB puts everything, all the database in memory. So you have to be very careful when you have more complex service packages that you have created within the context of NSO and Docker. So that's why we recommend NSO in Docker for now. And in the future, it might change. But for now, we recommend to be used in the dev and test labs itself.
Thank you very much, Oswald. All
I
right.
also have a comment
Sure.
to that question as well. And my name is Oleg Stritzman. I work in the NSO CTO team, so I've been involved a little bit in the development of NSO and Docker. And what I can tell you about the future is that with NSO 6.1, we have plans to support NSO running in a container. So I hope that the recommendation to run NSO in Docker will change with NSO 6.1. And I would say the biggest benefit of NSO in Docker is that you can achieve a CI/CD pipeline where you where you have the code running in production is the exact same code you have been running in your test environment. Thank
Awesome.
you.
Thank you. And for those CI/CD, continuous improvement and continuous development, correct?
Was it a question for me?
Oh,
Yeah.
no, just expanding on CI/CD for people who may not be aware of that
Okay.
acronym.
Thank you.
Awesome. Thank you. All right, moving on to our next question. Is NSO in a Docker environment supported by TAC?
I think I answered that question. Right now, no. The answer is no.
Gotcha. Thank you very much. All right, next question I have here is, can I create and test services and validate device SYN functionality?
The answer is yes, to a scale, right? Like as I said, depending upon what you are testing in your stage environment, the features and functionalities that you would normally get in a local install or in the system install are comparable or equal. I would say same, like what Ulrich mentioned, for you to test it against your NetSIM devices or your devices in your lab environment.
Thank you very much. I think we have time for one more question. Question is, can I run the NSO GUI dashboard functionality with NSO in a Docker environment?
I will answer that as well. Yes, Miguel kind of showed it's how easy it is to map various ports from the Linux host into your Linux container itself. And within, when you run the Docker run command, you specify that you want to enable, like I mentioned that in my presentation as well, the HTTP enable. You set those parameters which map to the ncs.conf file. And once you do that, you will be able to connect through HTTP into your Docker, into your NSO GUI. So it's fully supported. You can, if you are comfortable in creating packages or leveraging some alarms or looking at alarms through your NSO dashboard, you have all those features and capabilities.
Awesome. Thank you very much, Oswald, and pretty much the rest of the team. We've answered all the questions. Oswald, Miguel, is there anything else you'd like to say to the audience before we wrap up?
I just want to thank everyone, the panelists for answering all the questions, the attendees for taking the time. Thank you so much. And if you all are interested in more subjects that we would like to share with NSO, please let your account team know. Your CX organization is here to help you and make you an NSO expert within your company itself.